Hi guys, welcome to part 4 of this video tutorial series. In this video, we will be getting into propagating these string logs into our factory. But before we do that, I would quickly like to introduce first the singleton design pattern. So if we notice, our factory has one method called create event, and the behavior of this event would be the same irregardless of the instance or the object we are using for the event factory. Typically, this scenario is handled by making this method static because the behavior doesn't change from one object of this class to the other. But in this case, we are implementing an interface, so we cannot have this method to be static because it comes from the interface. Now this is where the singleton design pattern comes in, because the factory always does the same thing, so we only want one instance of the factory to ever be created. We don't want to have an overhead of creating different objects that do the same thing, so this is where we need to apply the singleton design pattern. So our backend logs event factory will be a singleton. Now in Java, the easiest way to implement a singleton, and also the best way, I would say, is by using an enum. The only disadvantage of using an enum is that it cannot extend any other class, because enum are special classes in Java that extend the abstract class enum. So if we want to make this extend any other class, we cannot. But in this case, our factory doesn't need to extend any class. We're already implementing an interface, and this is good enough. And by the single responsibility rule, this should not be extending or doing anything else. So we need to define our instance name. So let me just call it instance. And this is like the only object that is ever going to be created for this this class. Now we need to provide a way to be able to get the instance, because enums by default imply that the constructor is private. So we can do backend logs factory dot event factory dot instance, but usually what the case with singletons is there's a get instance method. So we will just return instance. So this is basically the singleton pattern in play. We have our backend log event factory with only a single instance, and this implementation of singleton is also thread safe, and it's lazily loaded, because this instance is only created when we first use this class, and it is created at class loading time, which is thread safe. Next, we will work on propagating these events as string into our events collector component. So if you remember from the previous videos, the backend simulator module passes all events into our log file helper. Now we don't want to start creating the event factory and doing everything here, because we don't want to clog this log file helper, because it's an existing code, it's not our component. So all we're gonna do here is we're going to forward this log data into our events collector module. So we need to create an entry point that would collect this log data in our events collector module. So let's do that first. I'll call it events collector, and it will be just in the base events collector package. And in here we will just have one. So we could either make it a singleton or have a static method. In this case, we don't need to implement any other interfaces. It's just a class on its own, just like this one. So a static method would work for us. So we're going to make static void and for now I will just print it out to the console. Now in our log file helper, we want to pass the log data into our events collector. But remember that not all log data are events. So we only want the events collector to handle the valid events. So we're going to do a try catch so I'm going to create my own exception called invalid event exception that the events collector will throw in case that this event is not valid. So we will pass the event to the events collector, and then if it's invalid, then we will log it on our own, because this events collector will take care of logging the event for now. Later on we will do other stuff with it, like those which were specified in the requirements, but we'll get into that later. For now, let me quickly create this exception class, events collector. And we're just gonna extend exception. So with this, we have our log file helper passing the log data to the events collector. So you can think of this as a main method for our events collector. Let's start implementing our collect event. So the first thing we want to do is now convert this event string to an actual event object, which is what our factory is for. So first, we're going to pull an instance of our factory, event creation factory. We'll get the backend logs event factory dot get instance, and then we will try to create an event object. So dot this is event factory, sorry. Dot create event log string, and then remember that our factory returns null if this is an invalid event. So we'll go ahead and say if event is null, then we throw an invalid event exception. Now we want to deal with this created event. So I'm going to create a function called handle event, where we pass in the event. So this just makes our code cleaner by separating it out into a new function. So for now, I will just print out the details of this event object. So let's print out the occurrence time, the type, and the hash code, let's say. So let's see this code running. So what we expect is, for events, we will have it printed in this format, and for other invalid log data like these, they will be printed out as is over here, because we expect to get an invalid event exception. So let's run our code. So as you can see, all these occurrence times, we have got valid event objects. So that's the occurrence time, the event type, and the hash code as we printed out. And over here, these are invalid events, so these are being printed out by the log file helper in the catch exception block. So seems like everything is working well. We were able to capture our events. So I will be ending this video here, and in the next video we will get into satisfying the requirements that our manager gave us.